The secondary flight controls consist of lift augmentation devices, flaps and slats, lift dumping devices, spoilers, except when they are used for roll control, and air brakes and trimming controls. Some or all of these devices may be fitted to a particular aircraft. In this lesson, we will look at the operation of trailing edge flaps, leading edge flaps, and slats. The purpose of trailing edge flaps is to increase the lift generated by the wings at low speed. They are normally only used for takeoff and initial climb out, and approach and landing. They produce a lot of drag, so it is important that they can be retracted when not required. There are various types of flap design which all increase both lift and drag in varying amounts. A full explanation of the aerodynamics of trailing edge flap operation is outside the scope of this lesson. However, here is a brief summary of the most common types. Click on a flap type to view its properties and operation. The most popular type for light aircraft is the plain or camber flap, with trailing edge flaps, which are a combination of slotted and Fowler flaps widely used on large transport aircraft. This picture shows the triple slotted Fowler flaps on the Boeing 747 in the fully extended landing position. In a typical system, there is a flight deck selector lever. On light aircraft, this is mechanically connected to the flaps. But on larger aircraft, it will either be mechanically or electrically linked to a flap control valve. The flap control valve controls the flow of hydraulic fluid to a flap drive unit, which consists of a hydraulic motor and a gearbox. The motor drives a transmission system, which moves the flaps. In the typical system shown here, the motor drives the gearbox, which rotates torque tubes. They operate right-angle gearboxes, which in turn drive screw jacks to move the flaps. If either the hydraulic supply or the normal control system should fail, then a backup system, using either an alternate hydraulic supply or an electrical motor to drive the main gearbox, can be used instead. The system is monitored and controlled by a control computer. This computer looks after trailing and leading edge flap sequencing, as well as monitoring the system for malfunctions. If the flaps operate asymmetrically, and by that we mean the flaps on one side move out further than the other, the control computer will instantly stop the movement by shutting off hydraulic fluid to the motor and either closing a bypass valve and hydraulically locking the flaps, or operating brakes on the drive shafts. Similarly, if the flaps move without the lever being moved, or they overshoot the selected position, then again the computer will shut off the hydraulic supply and lock the flaps. The computer also receives airspeed information. If a flap selection is made at an airspeed above the maximum permitted airspeed for the selection, then the computer will not allow the flap to operate until the speed is within limits. Similarly, if the aircraft is accelerated above the limit speed for the current flap position, then the computer will cause the flap to retract to a safe position. This is known as the Flap Load Relief System, or LRS. Wing leading edge devices may consist of slats, Kruger leading edge flaps, or variable camber leading edge flaps, or some combination of these. The Boeing 747, for instance, uses Kruger flaps on the inboard section of the wing leading edges and variable camber flaps for the outboard, while the Boeing 737 has inboard leading edge Kruger flaps and outboard slats. Whenever a mix is used, the Kruger flaps will invariably be fitted closest to the wing root. Leading edge flaps and slats are operated by hydraulic power or by air turbine motors, and are normally sequenced to operate with the trailing edge flaps. Leading edge flaps are hinge surfaces that extend by rotating downward from the lower surface of the wing leading edge. They only have two positions, retracted and extended. The Kruger and the variable camber flap look the same from the outside when they are retracted. Each is simply a flat panel on the bottom of the wing. When the Kruger flap extends, the panel maintains its flat shape. The variable camber flap, on the other hand, has a cam system which bends the panel into a curved aerofoil shape as it extends. The panel returns to its flat profile on retraction. Slats are sections of the wing leading edge that extend forward to an intermediate position to form a sealed leading edge. Or they can extend fully, forming a slotted leading edge, depending on the trailing edge flap setting. The leading edge flap or slat extension sequencing varies with aircraft type. On the Boeing 737, the leading edge flaps extend fully and slats extend to the midway position, when the trailing edge flaps extend to their first position. And when the trailing edge flaps are fully lowered, the slats extend fully. The sequence is reversed when the flaps are retracted. Whatever extension sequence is used, the leading edge flaps and slats will normally be retracted when the trailing edge flaps are retracted. Alternate operation of the leading edge devices may be by a standby hydraulic system, or, in the case of those powered by air turbine motors, an electrical standby system. Depending on the aircraft type, it may or may not be possible to retract the leading edge devices by the alternate system. Some aircraft types have an auto-slat system, which will automatically extend the slats from the intermediate position to the fully extend position if the aircraft approaches the stall angle of attack and the slats are not already fully extended. The trailing edge flap and leading edge flap or slat positions are displayed on the flight deck. On older aircraft, this may be a simple double pointer gauge, as shown here for the trailing edge flaps, with the leading edge flap and slat positions being indicated by coloured lights. On more modern aircraft, the positions may be displayed on an electronic screen. As you have seen previously, the electronic display is able to provide a lot of information. In this Airbus system, the selected flap position is shown on the indicator. When the flap lever is moved, the new selection is displayed in cyan. It will change to white when the flaps reach the selected position. And in the event of a fault, it will change colour to amber. That is the end of the flaps and slats lesson. Here are the main points from the lesson. Light aircraft usually use plain or camber trailing edge flaps, while large airliners use hydraulically operated slotted Fowler flaps. Leading edge flaps are hinge surfaces that extend by rotating downward from the lower surface of the wing leading edge They only have two positions, retracted and extended. Variable camber flaps have a surface which bends, increasing its camber as it extends. Kruger leading edge flaps are usually placed inboard. Slats are sections of the wing leading edge that extend forward. They may have an intermediate setting, as well as being able to extend fully. The leading edge devices are normally operated either hydraulically or pneumatically.